Hello, this is Mrs. Grisafi. We're on 10.04 for geometry today, and this will probably be wrapping up our circles unit for us. So again, just like with the angles, there's a lot of rules that apply here. So once you know the rules, it's just kind of substituting in, but it's important to understand how these rules are set up. So in order to do these, you also need to go back and look at your vocabulary of what the lines are. So here we're talking about two chords intersecting. Also really important here to keep in your mind separate the angles and segments. So when you look at a question, you want to make sure you're thinking for these that you're looking at lengths of segments. You are not looking at the angles. So we've seen these two lines before in a circle, but we looked at the angles that they formed, and we did the angle here equals the sum of the two arcs divided by 2. But that's going to be different now because we're not looking for the angle, we're looking for these lengths of each segment. So when we talk about this rule, we're talking about where these two chords meet right here. Our rule for this is we say we take part of the chord, so from where the chord hits the circumference to the intersection of the chords, times the other part. So from continuing along that same chord from that intersection to the other side of the chord, and that will be equal to, for some reason I can't use my tools. We're going from the end of the other chord to the intersection of that chord. So that would be C, there's another part, times the rest of that part. So from the intersection to the other end of the segment of that chord. So the rule is part times part equals part times part. So in terms of these letters, you would take A, the length of A, times B equal to C times D. And these right here should always make up. If you were to add A plus B, it should equal the entire chord, that entire segment. C plus D should equal that other entire segment, the other one that's intersecting it. All right, let's look at an example. Number 1, find the value of X. Again, we're talking about lengths of segments. So here's our intersection point. So we take the first part here, so that's X minus 2, times the other part, which is X plus 6. Set that equal to the other chord, so 16 from circumference to the intersection times the intersection to the rest of the circumference piece. Okay, so now over here we need to FOIL this left-hand side. So we get x squared plus 6x minus 2, so plus 4x minus 12. And if you need to, you can always write out that. I was just doing it quickly here as well. Equals 16 times 3 gives us 48. And then we want to get that equal to 0. So we're going to subtract over our 48. And we get negative 60 over here. We have a quadratic, so anytime you have an x squared and an x, then you want to make sure you factor. So since there's a 1 in front of that x squared, I'm going to just use guess and check here. So x and x, I want two numbers that multiply to negative 60 and add to 4. So that's going to be positive 10 and negative 6. So 10 minus 6 gives me 4. 10 times negative 6 gives me negative 60. Set each of my factors equal to 0. And I get x equals 6 and x equals negative 10. Now I just want to do a double check up here to make sure that both of these work. So if I sub in 6 in for x, 6 minus 2 is 4, that works. 6 plus 6 is 12. Get two positive numbers. That's definitely one of my answers. Negative 10, if I sub in a negative 10. So it's okay to have a negative for your x. What's not okay is to have a length of a segment be negative. So when I substitute it back in for this length of this segment, negative 10 minus 2 would be negative 12. And I cannot have a length of a segment be negative, so I reject the negative 10. So I have one answer, and that's x equals 6 here. Okay, so the next one, if you're feeling up for it, pause it, see if you can at least set it up. I would try to go ahead and solve it as well. With this lesson, that you're getting a lot of practice with your algebra skills as well, which is really, really important as we end this year and as we begin next year in the fall. You want to make sure your factoring skills are where they need to be. So go ahead and pause, try it out, and then I'll go over it back here. Okay, so again, I have two chords intersecting, so I'm going to do 9 times the quantity x plus 2 equals 2 times x squared. It's a little hard to read there, but that's an x squared. All right, I'm going to distribute my 9, so 9x plus 18 equals 2x squared. I have an x squared and an x, so I want to get that equal to 0. So I'm going to subtract the 9x and the 18 over to the other side since I want to keep my x squared positive. So now I have 2x squared minus 9x minus 18 equals 0. Now here I have a 2 in front of my x squared, so this is when, and no GCF, here's where I want to use P's and C's. So let's review that. So P is the product of the first and last term. So 2 times negative 18 is going to give me negative 36. Then I'm going to have the C, which is my center term. That's going to be negative 9. Now I'm going to write this out. I'm going to take out the negative 9x and leave 2 blanks in place of it, but still keep my first and my last term of 2x squared and negative 18. Now I need to find two numbers that multiply to negative 36 and add to negative 9. Again, your quick trick, if you need to, you can always go to your y1 and type in negative 36 divided by x, and then go to your table and look for two factors that will also add to negative 9. So for us, let me switch colors here. That is going to be our negative 12 and positive 3. And then I'm going to group these up. First two, group the last two, factor out my GCF of 2x, leaving me with x minus 6. Here I'm going to factor out a positive 3. When you factor out your GCF, you always take the sign of the first term in your set of parentheses. So this is a positive 2x squared. I took out positive 2x. This is a positive 3x. I take out a positive 3. Make sure your parentheses match exactly and then factor that out. So you're going to write that one once, and then your leftovers go in the other set of parentheses. So 2x plus 3. Now that's our factored form. Now we're going to set each of those equal to 0 and solve. I get two answers. I get x equals 6 and I get x equals negative 3/2. Now we're going to substitute those both in to make sure those make sense. So if I square both of those, then we're going to be good. So the only other one I'm worried about is this x plus 2. So if I take negative 3 over 2, so that's just negative 1.5, and I add 2 to that, 2's bigger, so I'm going to get a positive answer. And 6, if I add 2 to that, then I'll get a positive answer. So for this question, number 2, you have two different answers, and I want you to draw your attention that x is equal to a negative number. It is okay for x to be negative. It is just not okay for the segment length to be negative. Okay, so two answers there. That's your two chords rule. So part times part equals part times part. Next up is if you have two secants. So if you have two secants, then we're going to take the length of the entire secant. So we're going to say that's the whole times the outside of the secant. So what I mean when I say outside is I want the part where that secant hits the circumference and the part of that secant that's outside of the circle. Okay, so we're going to take the outside, multiply it by the whole secant, and that's going to equal the same thing for the other secant, the outside of the other secant times the whole secant. All right, so in terms of our letters here, my outside is A, my whole thing, see that dotted line is B, my outside for the other secant is C, and the whole thing is D. So that's our next formula. Let's try it out. Number 3, find the value of x. So here is my entire secant. So they didn't give it to me this time, so I need to find it. This is my segment addition postulate. This piece over here is 1. Obviously, these are also not all drawn to scale. This is 1, and this outside part is 3x. So if I add them together, I'd get 3x plus 1. If I add this side over here to find the whole secant, I would get 5 plus x. Then my outside pieces is this orange piece and this blue piece here. Okay, so let's try this. So we're going to take the outside, which is 3x of the orange, times the whole, which is 3x plus 1, equals the outside of that blue piece, times the whole, which is 5 plus x. And once you've got that, once you've figured out the formula and you've substituted in, it's just an algebra equation that you need to solve. So now we're going to distribute, and we get 9x squared plus 3x equals 5x plus x squared. I have some terms here that I want to combine, so I want to get my x squareds together. So I will get 8x squared. And I can also combine my x's, so I'm going to subtract 3x over here. Now I subtracted my x squared over first because I wanted to make sure I kept that positive. Okay, so now I have 8x squared equals 2x. Remember, anytime I have an x squared and an x, I want to get it equal to 0. So I'm actually going to subtract this 2x back over here. So it would have been faster if I had just subtracted my 5x over, but a lot of students don't think to do that. So that's why I took a longer route here. Now, this is the one where a lot of you guys struggled on one of the past homework assignments. So it actually should be faster to factor, but a lot of you, I think just because it doesn't look as familiar to you, you haven't done it as often, that you kind of get stuck and not sure what to do. And some of you guys did quadratic formula, which would work, but if you do it correctly, but it's a lot longer. So instead, you always, once you get it equal to 0, always look for your GCF. So our GCF here, I can take out a 2x from both of those. So if I take out a 2x from each, 8 divided by 2 is 4, x squared over x is x. And then 2x divided by 2x is 1. And that's as far as I can factor it. Now I just have to solve. So set each equal to 0. So 2x equals 0. 4x minus 1 equals 0. Solve. Here I'll get x equals 0 if I divide both sides by 2. And here I'll get x equals 1/4. So now let's see if they both make sense in the problem. So if I put a 0 in here for x, or here, I would get 0 for the length. I have a secant, so it has to extend outside the circle, so 0 doesn't make sense. So 1/4 would be the only option here that would work. Okay, so we have one answer, which is 1/4. And then, of course, always go back in, sub, make sure that they add up nicely, double check all your work. All right, number 4, good place here to pause and see if you can do this one on your own. It should be a little bit easier in terms of the algebra. Okay, so hopefully you took your whole piece and then you multiplied it by the outside, which would be 4. Here, if I add those together, I get 16 times the outside is 6. Distribute my 4 in, I get 16 plus 4x equals 96. Subtract over my 16, I get 4x equals 80. Divide both sides by 4, and x is 20. Make sure that's a positive length, and it still is. So that will work. So that's it for that one. So no quadratics there, just basic linear equation. Next rule is called the tangent and secant rule. Why? Because it's made up of a tangent, which remember hits the circle exactly one time, and then a secant, which is what we just talked about, and a secant cuts through the circle 2 times. So it's going to hit that circle twice. Versus a chord would have stopped right here and just been completely inside the circle. A secant goes outside the circle as well. So in terms of the secant, it's going to keep the same rule as we just talked about. It's going to be the outside portion times the whole length of that segment. And for the tangent, we're going to set it equal to the tangent squared. Okay, so outside times whole equals tan squared. Let's try, and in terms of the letters, so outside is B times the whole is C, and the tangent is A, so that would be A squared in terms of those letters. Now let's try it on these problems. So the length of the whole secant here is 3x plus 11. And the outside portion just from here to here is x equals, here's my tangent. And another note that I should have made here is assume that these lines are tangents, hitting exactly 1 point. So we're going to square that. And now we're just solving. So we distribute in, we get 3x squared plus 11x equals 4. I have an x squared and an x. Anytime I have an x squared and an x, I want to get it equal to 0, and I want to keep x squared positive. So I'm subtracting over my 4 right here, getting it equal to 0. I do not have a GCF, and I have a 3 in front of my x squared. So that indicates to me if it's not a 1 or there's no number written in front of the x squared, I use guess and check. If there is a number, it's not a 1, then I want to use p's and c's. So my p again is the product of my first and last term. So 3 times negative 4 is negative 12. C, my center term, is positive 11. I'm going to take my problem, take out the middle term and replace it with 2 blank x's. I need 2 numbers that multiply to negative 12 and add to 11. So that's going to be positive 12 and negative 1. So 12 times negative 1 is negative 12. 12 minus 1 is 11. Group your first 2, group your last 2, factor out your GCF. So here's a 3x. Here, the first term is negative, so I'm going to take out a negative 1. And the biggest I can take out is 1 from both of those. So if I divide both of these by negative 1, I'd be left with x plus 4. These 2 parentheses should be the same, so pull out the x plus 4, and your leftovers, the 3x minus 1, goes in its own set. Now set each of these equal to 0. Make sure you show this step of setting them each equal to 0. It's a very important step. And we get negative 4 and positive 1/3. So if I go back to the problem, will both of them work? Well, 1/3 will definitely work for both of these. They'll stay positive. Negative 4, since this right here is just x, that would be a length of a segment. So we have to reject that negative 4. So we have only one answer, and that's positive 1/3. Here would be a good place to pause the video and try the next one on your own. Okay, so here we have a secant tangent again. So we're going to take the length of the entire secant, which is 12, times just the outside portion of the secant, which would be 4, equals our tangent squared. Now I get 48 equals x squared. I have an x squared, but I do not have an x. So I don't need to get this equal to 0 to factor it. Instead, I just want to solve for x. So I'm just going to take the square root of each side. And whenever I take the square root, I need to make sure I remember my plus or minus. And I also want to put this one in simplest radical form. So I can take out 16 from 48. And again, if you are unsure of the largest perfect square, you can always do your 48 divided by x and then go through and look for perfect squares. So rad 16 times rad 3. So I get plus or minus 4 rad 3. Let's go up and see if both the positive and the negative will work. So since x is a length of the tangent right here, it cannot be negative. So we have to reject that negative. So we have only one answer, which would be 4 radical 3. And our last rule we're going to talk about is if you have 2 tangents. So again, tangents are these segments right here that hit the circle at exactly one spot. So it just skims it. We call this one our hat rule. Think of a little party hat. Look at this guy or girl with those eyelashes. Just beautiful. So here's your party hat. Party hat sits on straight. Think of these sides of your party hat are always going to be the same. So with the tangent rule, the 2 tangents will always be equal. So the length of AB will equal the length of BC. So your tangent will equal your tangent. So pretty straightforward rule to follow. The hard part is keeping all these straight and remembering what they are. So for number 7, I have 2 tangents, so I'm just going to set those equal to each other. Here I do have an x squared and an x again, so I need to get it equal to 0. So I'm going to subtract the 11x and the 20 over to the left side since 3x squared is already positive, and I always want my x squared to be positive. There's no GCF, and there's a 3 in front of the x squared as opposed to a 1 or nothing. So whenever there's a number in front of x squared other than 1, we're going to use P's and C's. We multiply the first and last term. 3 times negative 20 gives us negative 60. Center term, negative 11. Take out the negative 11x, replace it with 2 blank x's, keep the first and the last term there, and figure out what multiplies to negative 60 and adds to negative 11. And we're going to use negative 15 and positive 4. Group up, factor out your GCF. Here, take out a positive 4 since the first term is positive. Make sure your parentheses are exactly the same and rewrite that one time. And then your leftovers go in their own little set of parentheses. Set each equal to 0 and make sure you show that step. And we get 2 answers. We get x equals positive 5 and we get x equals negative 4/3. Make sure you remember to sub in to check. So here, go ahead and substitute those in and see if you get positive values. So the 5, you can probably tell that by just looking. But a good idea to check it anyway. And then the negative 4/3, you definitely want to check that one since it's negative. So negative 4/3 times 11 plus 20 would give you 16/3. And if you square negative 4/3 and you get 16/9, and then multiply that by 3, you get the same thing. So they're both positive. So in this case, again, you keep both answers. You keep the negative and the positive because you will not, when you sub in that x, it does not create any negative segment lengths. So it's okay that x is negative, it's just not okay to have a negative segment. Next up, number 8, good idea here, pause the video, see if you can do number 8 on your own. All right, so I'm not going to go through the whole thing here because we've done P's and C's a few times on this set of notes. So if you need practice with P's and C's, go back and check one of the earlier problems or the last one we just did. But you would have to get this equal to 0 first. Getting x squared positive, use your P's and C's. For this one, you should have 2 answers. Again, it should be negative 3/2 and x equals 4. And both of those we would keep, okay? And again, just make sure you substitute in your answers to check that they both be positive and equal. Of course, check that these two are still equal when you substitute them in. All right, and number 9 looks a little bit different. It's actually a pretty fast problem, but you just have to think about it a little bit extra since it looks different. So here we have this triangle drawn around this circle, and all of these segments right here are tangent to the circle, so they hit exactly once. So right here, you'll see you have 2 tangents. So if these are both tangents, this is one little hat, this is 4, then this side would be 4. Here you have another hat, 2 tangents. So if this is 3, this is 3. Then you have another hat up here. So if this is 2, this is 2. So now we're looking for x. So I didn't even need to find the 2. And I know the orange part is 3, the purple part is 4. 3 plus 4 equals 7. And that's it. So you're just looking for the tangents. Again, it would state that those were tangents to that circle. All right, so in summary, I just want to write out your 4 rules that you guys needed to know. So if you have 2 chords, that one's going to be your part times part equals part times part. A tangent and secant rule, then you're going to take the outside of the secant right here, multiply it by your whole secant, set it equal to your tangent, which is over here, squared. Over here, sorry if you're hearing Gianni wake up a little. 2 secants, we're going to keep the same rule for the secant as we did before. So outside of the secant, times the whole secant. Set that equal to the outside of the other secant times the whole other secant. And then the last one is our hat rule. If you have two tangents drawn from the same external point, then they will be equal to each other. Tan equals tan. And those are your four main segment rules that we are going to be using. So identify what types of lines you have. Do you have chords, secants, tangents? And decide what rule it's going to be. Once you decide on the rule, substitute in, and then solve. And whether that means taking square roots, solving a quadratic, using P's and C's, factoring, do whatever algebra you need to do to solve for x. And that is it for the 10.04 notes and wrapping up the circle unit as well. All right, I hope you're all doing well, and pi out.